Motion geometry. Set and function are the two basic concepts that has been given mathematics a unified structure. A generalized concept of function in geometry is given by mapping and transformation. If we consider the map of any country, we know that every place in India is represented on a sheet of paper and it is called the map of India. We can see that every point in India is related with one and only one point on the map and Venosary. Every point on the map represents one and only one point in India. It is one-to-one correspondence. So, we can say that India is mapped on a sheet of paper. If you copy the map of India on a sheet of paper in your notebook, then it is mapping of the sheet of paper in the atlas onto a sheet of paper in your notebook. It is mapping on one place to another. Transformation is one-to-one correspondence among all points in a plane on the space. A mapping which matches every point P of a plane X to a unique P of the plane is called a transformation of the plane onto itself. P' is called the X image of P, which is written as symbolically X of P equals to P'. In motion or transformation geometry, we are concerned with various types of transformation like reflection, translation, rotation and their compositions. A transformation preserving length is called an isometry. Mapping. The process of plotting or getting P1 from P by making use of a line L is called reflection in L or symmetric mapping with respect to L. P1 is called the image or map of P in L or the reflection mapping of P in L. It is also be said that P is mapped onto P1 by symmetric mapping in L. We express it symbolically by L of P equals to P1. Note that if P is equal to P1, then P1 is equal to P. Finding the reflection image of a point in a line. Let L be the given line and P be the given point in the same plane. Draw PO perpendicular to L. Produce PO to P1 such that PO is equal to OP1. Then P1 is the reflection image of P in the line L. Or invariant points. Draw a line L on a sheet of paper. Let P, Q, R, S and so on be the points on it. Fold the paper along L. Then the P, Q, R, S and so on do not produce new points. A coincides with A, B coincides with B and so on. L of P is equal to P, L of Q is equal to Q, L of R is equal to R, L of S is equal to S and so on for every point on L. Such points are called fixed or invariant points of the mapping L. In reflection in a line L, points belonging to L are fixed or invariant points. The line L is also invariant. Line symmetry of two given points. Let us plot 2 points X and Y on sheet of paper. We can fold the paper along a line, say L, such that A coincides with B. Then this line L is called the line of symmetry of the points A and B. Note that X and Y are reflection images of each other in L. Symmetry of a figure. A line L about which a figure can be folded in such a way that each point of one part coincides with corresponding part of the other part is called the line of symmetry of the figure. In the given figure, L is the line of symmetry. Some figures with their line of symmetry are given below. But some figures have more than one lines of symmetry. Some figures has no line of symmetry. For example, a scalene triangle has no line of symmetry. How many lines of symmetry a figure has depends upon the nature of the figure. In general, a regular n-gun has n lines of symmetry. A circle has an infinite lines of symmetry. Circular lines. If a line Y, which is different from L, is mapped onto itself by reflection in L, then Y is said to be perpendicular to X. We know that perpendicularity is a symmetric relation. So if L is perpendicular to Y, then Y is perpendicular to L. Reflection of a line in a line. Let X and Y be two lines in the same plane. Let us find the reflection image of y and z. Mark 2 points A and B on y. Locate A1 and B1, the images of A and B respectively in X. Then A1 B1 is a reflection of AB in Z. Observe that point A lies on one side of line X. Its image A1 goes to the other side of X. That is, points on one side of X goes to points on the other side of X. Fixed lines. Let A and B be 2 points on L. Since A and B are points on L, their reflection images in L are themselves, as they are fixed points. So, the reflection image of L in L is itself. So, it is a fixed line. Now, let us consider whether there are any lines which go over to themselves in the reflection mapping. In the given M and N are perpendicular to L. Since M is perpendicular to L, L of M is equal to M. And since N is perpendicular to L, L of N is equal to N. So, lines perpendicular to L will be mapped on themselves. So, they are also fixed lines. Thus, the line L and any line perpendicular to L are fixed lines for the reflection in L. Reflection images of intersecting lines. In the given figure X, AB and CD are three lines in the same plane. O is the point of intersection of AB and CD. X of A is A1, X of B is B1. Therefore, X of AB is equal to A1 B1. Similarly, X of CD is equal to C1 D1. We can see that X of O is equal to O1. A1 B1 and C1 D1 are also intersecting lines. We can see that intersecting lines with their point of intersection are reflecting and intersecting lines, intersecting at the corresponding point of their intersection. On measuring angle AOC and angle A1O1 C1, we see that they are equal.